Welcome to the PowerPoint on the scientific method. What is it? Why do you need to know it? Will it help you? Yeah, it will. It's not just research, which is what the understanding of what you use the scientific method for is doing research in a field, education, biology, chemistry. All of those scientists or researchers basically use the steps of the scientific method. It's just a method of organization of thinking. And that's why it's so important to learn, because you can use it every day. It's not just research. It is how you look at things so that you can make decisions. And sometimes it involves looking at things in ways you have not looked at before. It is very systematic, which means there's one step leads to another step, leads to another step. Feelings are subjective. Objective is stuff you can measure. Well, we do have some of the softer sciences use the scientific method as they try to make things objective, like pain scale. How is your pain rated? Physical therapists use a scale based on 0 is no pain, 10 is intense pain. So now we're putting a number on pain. Of course, everybody feels pain differently, but the research has been done using this scale, and it's a good scale. It's for the most part accurate. And here we're measuring something that's very subjective. But we have now made it objective so that insurance companies pay for medical treatment of pain. So in the end, the scientific method, when you use this process, you come to some kind of conclusion. Now, if you're looking at why scientists use it, it does keep things in an orderly fashion. It is reproducible. That means the steps have been documented or written down and can be done over and over to prove that the first person's results are accurate. And that's what you're going to look at. Are the results valid of research? So we're looking at research, but for the purposes of this class, obviously you're not doing research. Now this is just another model of the steps of the scientific method. I'm not going to stick on this page too long. You could print it. There's one in your textbook. I have many in my presentations. But the whole thing starts off with an observation. That's the top left corner. You observe something. Why does something do something? Why is that girl's hair black? Why is she choosing to eat cake versus healthy food? Okay, you have a question, an observation. Now you're going to do and try to answer it. And that's what the scientific method is. Obviously, some of the questions are a little silly that I just proposed, but you can come up with a numerical scale like we did with the pain for this one situation, and it may be reproducible with another situation. So the purpose of the research, we're going to go through step by step of how you do the steps of the scientific method. And the first thing is the purpose, the observation, and it's usually stated as a question. And the question has to be a good question. In other words, you need to exactly say what you're questioning. Is fertilizer good for plants? Well, it could be. It couldn't be. How do we know? What fertilizer? What plants? What happens when they get fertilizer? Now, the example below that, do plants grow taller when treated with fertilizer? Okay, now we're looking at height and fertilizer. So those are the two things we're going to be considering to do this research. Is what type of fertilizer, obviously that has to be identified, and then what plant and how much taller. What are we looking at? A percentage? It depends on the plant. So there's a couple of things that I'm saying depends on, and that's what gets defined in this research that you're going to do. You've got to finalize the question, and that's the beginning. That's the first step. So now you start doing a little research. You always have to do research before you do the research. You got to know what you're talking about. You can't question something if you don't have a background information. You've got to understand what you're questioning. Fertilizer. What kind of fertilizer? Do some research on fertilizer. What plants grow taller based on previous research? Pick a plant. What area? What part of the state do these plants grow in? Or what part of the country? Obviously, in New England, we do not have saguaro, which are huge cactus that are only in desert areas. So there's many different things you need to gather knowledge about before you can really start your research. You need to identify and clarify and make things more specific. So you're going to go to experts, you're going to read, you're going to use the internet, go to school, any number of things to start to gather your background information. Then you've got to come up with a hypothesis. Now, this is going to be a term you're going to hear a lot. A hypothesis is sort of like a prediction. In fact, the lab book puts hypothesis first, then prediction below it, but they're so closely aligned. A hypothesis is a statement or an educated guess based on the knowledge and experience you gained with your background research. So we're going to test something. Something has to be testable. You don't have a hypothesis that you can't test. How would you design research? You've got to have something that's specific. You got to know what you're testing, or you're not going to get an answer that stands up for other researchers. So a hypothesis is often described as an educated guess, but it is what defines the question. So the hypothesis is going to actually define the research. For the purposes of this class, this is the way you're going to write them. There is a reason. It helps you organize your thought processes. But they should be in the format, if I do this, then this may happen. And it has to be specific. You got to clearly identify what you're testing. And if you don't, if it's not a specific testable format, it's not a hypothesis. And that's the key to writing a hypothesis. So it's an educated guess or a potential answer. It's a possible answer to the question you had in the very beginning. And when we say address causes that lead to effects, that's the if-then type of thing. If I do this, then there'll be this effect. So what you're proposing is the cause as a result of predicting something. I know this sounds like gobbledygook, but I'll help you as we go along as to what and how to write a hypothesis, and the way I give you is a very simple template. So the hypothesis is a tentative answer, a possible answer, or an explanation of a question. The only thing is, it must be a specific question. Like the first question that we looked at with the soil and fertilizer and plant. You have to look at a specific trait. We looked at height. And with the hypothesis, you are making a prediction, and it's going to be researched. It's going to be tested. And that's the whole purpose. You're going through the steps of the scientific method, and we're now on the second to third step. First, there's a question. Second, you do background research. 3, you write your hypothesis. Here's an example of a good hypothesis that I recommend you come back to this before your final exam in the lab, because you have to write one. And here is an example. If patients are given drug X, very specific drug, we could say aspirin, 10 milligrams, then their tumor size will decrease by 10%. So if the tumor was 10 centimeters big, it's going to lose a centimeter in size. So they measure the tumor and they say, okay, I'm going to give this patient this drug, and I expect to see their tumor decrease in size by a certain amount. Very specific, very testable. You know exactly how the research is going to be started. Now there's 2 other variables that we're looking at here. The independent variable and the dependent variable. The independent variable depends on the dependent variable. And when you write the if-then format, you are putting the independent variable, which is what varies, in the if spot, and the then spot, which if I do this, then this is what's going to happen, and that's what you measure. That's a dependent variable. Those are terms you're going to have to get used to. Variable is your unknown, or the thing you're changing, the thing you're testing. A variable can change. A constant does not. A constant like is 10. 10 is 10. It's not a variable. It's 10. You got 10 as something. Not telling you what. So now I want you to start thinking about writing hypothesis, and some of the work I'm going to be giving you deals with this. And that's why this PowerPoint is going to be important for you to review and keep for the entire course, because this is one of the objectives of Biology 105, is that you know what the scientific method is, that you've got a foundation, a beginning. You're not researchers, you're not going to be researching, but you need to understand it, the foundation for future science classes or for a future career. So a researcher would like to determine the effects of groundwater pollution on size of corn plants. They notice plants that are not exposed to water, polluted water, tend to grow taller. So how would you write that? Give it a chance and see if you can write it. After you write the hypothesis, then you do the experiment. The hypothesis is what sets up everything. There is a control group. The control group is what you compare everything to. it's not changed. It doesn't get the treatment. You've got to have something to compare to, or you'll never know if you made a difference. The experimental group gets the experiment. And then the independent versus the dependent variable. Those are the other two things. So those are the 4 pieces of an experiment that you play with. You can maneuver, manipulate. So you have to determine how you want to test it. How are you going to measure it? And the key to doing an experiment is only moving or changing one variable. You change 2 variables, you'll never know what caused the effect. You've got to change one variable and keep everything else the same. That way you can say it is due to this one variable that you saw the change you did. After you do the experiment, you're now ready to look at the data you collected. Now, we're not going to do that in this class. You may see 1 or 2 that I've put in some of the paperwork that goes with the scientific method and some of your homework and everything. But when they look at the data, say they collected data on the polluted water and the height of plants, they would want to measure the pollution, and they'd also want to measure the height of the plants. And then they're going to do this using all sorts of graphs and charts and tables. And obviously in this class we're not doing that, as that is, you need to learn this in math, and we have many students who have yet to have even covered this material. So it's there, and you're going to see charts, you're going to see tables, and it's all putting data, which is the things you measure. Then you look at the data, you look at what you found out, and you're going to say, oh, I was right. My hypothesis is perfect. Or, gee, my hypothesis isn't right. My guess was wrong. So now I need to come up with another hypothesis because what I tested was incorrect. So now you're going to come up with another hypothesis. And that's the thing about the scientific method. It can go on and on and on. Like AIDS research. There's research going on all over the world. Of course, with the internet, we have instantaneous communication between researchers. So that if one researcher comes up with an answer to what another one was testing, they can develop a new question. But you've got researchers looking at AIDS from many, many different perspectives, and each is very specific. But if you don't know what the other researchers are doing, you can't come to any conclusions. And that's the key, is that you need to put together all the information you gather and start another research project, another question. And in this case, the question, plants treated with fertilizer grow taller than those not treated with fertilizer. So that is what we found with the research. That was our hypothesis, that they would grow taller with fertilizer. Now, I'm not saying what kind of plants. We didn't say how much taller. We're just saying they grew taller. So, and we didn't say where, the plant. There was a lot of things left out of this, but that gives you an idea that it's very specific. The plants we treated with this fertilizer grew taller. And that's the conclusion you reach. So here are the steps that you go through. You go through the purpose, background research, questions, then the hypothesis, which drives the experiment, And then you collect data and analyze it and come to a conclusion. If the conclusion doesn't prove that your hypothesis was correct, you go and start all over again. You probably don't need to do background research unless your background research was very skewed and you only looked at one thing. You may have to broaden what you're looking at. And that's the whole key with the scientific method. And I went through some real research-based type of questions, but people use this in everyday life. And I will be talking about that in another presentation, or you'll be reading about it, because you do use this all the time, even if you don't realize it. So here is your overview. The hypothesis, which you have to learn how to write. There's an observation, a question, or a problem. That's what drives this whole thing. You make a testable prediction. That's how you're basically what you're doing with the hypothesis. And you write it as an if this, then this statement. And that's the only way I want to see them written in this class. There are other ways, but for purposes of keeping it simple, because that's all, I'm not expecting you guys to become researchers. I just want you to understand the process. And using if, then really helps you put the variables in the correct area and helps you make it specific and testable, which are keys to writing a hypothesis. So that's the end. And as you continue on, if some of this was confusing, now go do some reading and do some of the problems that I'm posting and homework, and then you can come back and listen to this again. And that's what I recommend, that you come back and you're like, oh gee, now I get it. Because after hearing this the first time, it may be confusing, but after you do it and start doing some problems and writing a hypothesis, you got to come back to this and look at the overview again. I wanted to keep this short, so bye.